The procedure today is the cold agglutinin, and my primary purpose for teaching it is to improve your serial dilution and your understanding of the calculation with the serial dilution. Cold agglutinin checks for Mycoplasma pneumoniae, an organism that can cause a pneumonia. And besides a chest x-ray, this is one method that is tend to show positive because you have an eye antigen on 99.8% of every person's red cells. And when you have Mycoplasma pneumonia, these patients develop an auto anti-eye. So the premise of the test is to clump red cells if you have this Mycoplasma pneumonia causing your pneumonia, and the auto anti-eye will clump the eye on either the patient's own cells or the patient's O red blood cells, because you don't have to worry about clumping taking place because of an ABO typing if you use O red cells. So today we will use the patient's own cells, but if you don't have the patient's red cells, you can definitely use O red blood cells because they will have the eye antigen, most of them. So let's label our test tubes again. This time we do 10. I do not have a positive control. I think these are too small. I do not have a positive control today. I try to get one from a blood bank donor that has a cold antibody that they detect. There's not an actual test kit for cold agglutinin. So today we will just run, Gene is the patient, 1 through 10, so 1 Gene and then 2J, 3J, 4J, and so on. And then our negative, we will put any G. So I'm a fan of getting organized first, and I'll show you the positive tube as well. I put POS in case I had one, but usually I come up with some way to show a positive in class when we don't have one. So you get your tubes labeled, and I'll keep our control tubes there. All I use for my negative control is 2/10 of saline. So the blue pipette, the bigger Eppendorf, I have set on 200 microliters, and I have my saline tube that I can work from, that I poured over from my stock, and I will put 2/10 of saline into my negative. The patient positive control, if I had one, I'd put 2/10 of positive control. But in this case, the saline is acting like my negative. My diluent for the patient is also saline. So I am going to put 2/10 into all 10 tubes. And if you notice, I haven't changed tips because it is the same reagent. And I go smoothly, press down on with my thumb when I pipette, and gently pull up the liquid, and then I rim it as I come out of my tube of saline so I don't have the excess on the outside of my pipette tip. Okay, so that's my diluent is saline. A lot of times you use saline or DI water or distilled water as your diluents when you're diluting your patient. The next thing I want to do is serial dilute my patient. So remember, I'll do 2/10 of my patient serum, which is Gene, and I'll add it to just the first tube. That is equal amounts, 2/10 to 2/10, so that made a 1 to 2. Then when you serial dilute, remember, you mix it, rim it as you come out, put it in your second tube. Then mix it, rim it as you come out, put it in your third tube. And you continue that all the way to tube 10. Now, unlike the RF procedure, this time when we get to tube 10, we are going to discard it because that gives us a pretty high titer that the patient would have if they went to the 10th tube and still showed clumping. And at that point in time, the physician's already going to know it is elevated. So when we get to tube 10, we'll actually mix tube 10, and then we will discard. So now all of the volumes, even in our negative control, which is only saline, has 2/10 as their volume. But remember, this added 2/10 a patient to the saline, so that was a 1 to 2. Then this added 2/10 of tube 1 to 2/10 of saline, so that doubled it. So it goes 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. So now we have to add red cells. And this sometimes is a part that the students, I'm going to set this aside, get a little, have struggle with. So we need a 1% or a 1 in 100. So I'm going to add 9.9 mils of saline, and it just has to be approximate, this dilution. So I drop it down to the 1/10 line on the pipette, and I put that whole volume, 9.9 mils. I used a 10 mil serological, and then I'm going to add 1/10 of washed red cells. Okay, so when we wash red cells, I'm going to set this aside a minute. When we wash red cells, we take some from an EDTA or purple top tube, and what we do, we just want red cells, but we have to wash them with saline. So what I do is I take an aliquot, which just is a portion. It doesn't have any volume per se, like a mil, 2 mil. And I squirt it in the bottom of a test tube, and to wash it, I fill it with saline. And all I do is use the squirt bottle. The squirt bottle's not working too good. Usually it fills faster than that. And then what I do is I put a piece of parafilm on it. And one of the nifty things with parafilm, you don't have to use a lot. So we'll do a little bit of parafilm, and then I put a balance tube. All I do is put a tube of saline in across from it, and I centrifuge it for 30 seconds to a minute. And what I'm looking for is a clear supernatant. For some reason, this piece of this procedure throws the students a lot. So it's 9.9 mils of saline with a serological pipette. Just drop it down 1/10. It doesn't have to be perfectly accurate. I know I've told you before, you don't want to blow out from a serological, but in this procedure, it's okay. Then what we'll do, if the red cell supernatant, if the red cells are on the bottom and the supernatant is clear, they're washed good enough for the test. So what we'll do is, if it's clear, we'll remove all of the saline and the red cells are ready to use. If it's not clear, you'd repeat that same procedure. Take off the saline, put new saline in, but see how clear it is? When they're fresh red cells, they'll clear in one time. So you take off all the saline to, as much as you can get off, and just leaving the red cells. And then you want to take 1/10. This time I put the yellow pipette to 100/0, which is 1/10. You can use the blue or the yellow. And I go just to the first stop, pipette up my washed red cells. This time I don't just rim them. I like to take a chem wipe and wipe off the excess blood on the outside. Then I put it in my 9.9 mils of saline. I mix it to try to get all the blood out of the pipette tip. and then I put a piece of parafilm on. So this is one thing normally I like to make ahead of time and have all of it ready before I start. So now back to our test tubes. The last step is adding 2/10 of the 1% red cells. And if you when you make it, just like you have your saline tube, just put this as your 1% RBCs. And then what you want to do is add 2/10. Remember, just gently to the first stop on the pipette, rim it as you come out so you don't have the excess on the bottom. And you'll put this in every tube, all 10 patient tubes, the negative, and if we had a positive today, you'd put it in there too. So I'll just act like we have the positive and we'll add it to that tube as well. And this procedure, it's pretty nifty, just like the RF test. You can get an idea how your pipetting is by picking up the rack and eyeballing it, and all the test tubes should have 4/10 of a mil in. I'm going to go ahead and put the 4/10 in the positive just so it's equal volume, since we didn't have the 2/10. And it's a check. If you tilt it, you can see all your volumes match. Then we stick it into the refrigerator for 2 to 24 hours. Minimum is 2. And then once again, when it's done, these aren't settled out, but the red cells will fall in that 2 to 24 hours. And then what you will do is take your little blood bank reader, and after 2 hours to 24, just like we did the RF test, you will take your positive and your negative and your first patient tube, and once again, I like to put my patient in between them, and you look at the agglutination. This time you're going to look for clumps of red cells. If this person has the Mycoplasma pneumoniae, they'll have this auto anti-I that will clump the red cells. And if your patient looks like the positive clumps, you say positive. If it looks like the negative, you say negative. The one thing about the cold agglutinin, there's no prozone, there's no excess antibody. So if tube 1 is negative, you're done. And you don't report it less than 1 to 4. You report it negative. And then the last thing I want to show you is how do you get your dilutions. This confuses all the students. So remember, before we added the red cells, you had 2, 4, 8, and so on. Doubled the reaction. You had 2/10 left. We added 2/10 on top of that of red cells, which doubled the reaction. So that made it from a 2, we doubled it, so it's 4, 8, 16, 32, 64, 128, 256, 512, 1014, 2028. And remember, these were our 2 controls.